these things. So I'm going to just try this because I've never done this before. I always do this in the computer. I'm going to try and give these the same, almost the same initial conditions. And let's see what happens. No. No, it's not. For some initial conditions, the chaos is low. You notice that was a small perturbation. But they're looking pretty much like what you'd expect. Okay, so let's study one first. So I just barely moved, and why would you get a different answer? I did the same thing. So let's use one of them though and see what happens if I do this. I'll have to speed this up. I have to find an even better condition. This way, wait. So I really had to give it. Okay, that's what we're. So this is non-periodic. Isn't it cool? Now the thing is, the way I did it the other time, if we had waited long enough, and if there was no friction, it eventually would have done something like. Okay, so now let's do the same thing with both of these. I'm going to try and do this exactly the same, okay? Does that look about the same angle? All right. But you see how they deviate really quickly, right? You ready? Is that the same angle? No. Really? Yes. That's got it. Ooh. We're not tearing this building down. Oh. I didn't do that either. It's going to get harder. Well, let's. How's that? Sure. Is this one be lower? Whatever. Ouch. That good? Yep. Really close initial conditions, totally different motion. And here's the other thing. Even if you were to map exactly how different those initial conditions were, you could not predict what it's going to do. You could say it's going to do, maybe it'll do the twirly thing 3 times out of every 12, but you couldn't say, oh, now it's going to do the twirly thing. You just wouldn't be able to do it. You don't know what's going to happen next. You know statistically what's going to happen. Now they're starting to damp out. And as they start to damp out, they start to look a little bit more similar. I want to try something. I've never done this. This is really you should submit it really hard. That one hardly did it at all. There it goes. So not to freak you out, but the solar system is just like this. In fact, no, if you make 100 million simulations of the 8 planets, so let's include Pluto, 9 planets. Let's say you do 100 million simulations, which is machine precision in your computer. 2% of the time, in the next 2 billion years, Mars and Venus switch positions. In the simulation, it's 2% of the time. Now, I can't predict whether or not Mars will switch positions with Venus. Hey, that only happened. It would be. But there is a 2% chance that in the next 2 billion years, the chaotic nature of the system, and this has happened before, so I don't know if you're aware of this, but Jupiter and Saturn formed out, and then they migrated in because of drag with the disk of the solar system. And then they got to a point where they're in what's called a resonance, where They go around like Jupiter would go around twice every time Saturn went around once. And that caused everything else in the solar system to flip out because they're always at the same spot in their orbits. And then they started migrating back out again. Right? During that whole thing, there was chaotic motion in the inner solar system. We could have had a bunch of Earth-like planets form, get scattered out, get formed again, get scattered out, get formed again, and then now that's what's here. And like I said, in the future, there's a very small chance that the planets will reorganize